Yeah, so I'm Ken Wheeler, Ken_Wheeler on Twitter, if you want to read a bunch of hijinks and shenanigans. And I'm the director of open source at, what was that sound? At Formidable Labs. It's a consultancy based in Seattle where they do a lot of Node, React, GraphQL. I work from New Jersey because I'm an HR liability, but everybody else there is really nice people. And boom. About 500 people just lost the circle game. I get to hit each and every single one of you. Sorry. With that said, I'm not getting into the talk just yet. I released an album like 3 days ago. Right? It's called Love Songs for Your Mother. It's like 80s like roller rink birthday party music. It's love songs for your mother, not my mother. Everyone else's mother, except for mine. But yeah, it's on Google Play, Spotify, your mom's iPod Shuffle, whatever. Just check it out. It's pretty cool. But yeah, all that aside, I'm here today to talk about how ReasonML is serious business, and how suddenly this makes sense. Okay. So Reason. Can I see a show of hands who's heard of Reason? Can I see a show of hands who's used Reason? That's why I'm here today. All right. So what is it? So it's a new syntax and tool chain for the language OCaml. OCaml allows syntactic extensions on top of the language, like kind of built in. It's like built-in Babel almost. So this is a new syntax for the OCaml language. And it looks a whole lot like JavaScript. And speaking with the people who are creating it, who actually made React, looking like JavaScript I don't think was like a primary goal, but it just ended up that way. And in addition to that, it uses NPM and Yarn-based workflows. So, in our everyday, that works pretty well. So you do installation or script running all through NPM. So if you write JavaScript, which I'm assuming most of the people in this room do, it's pretty familiar, right? So what about this OCaml business, right? So OCaml is a general purpose systems programming language. This is like a native language. It's a meta language. The meta language family, they had the original, MLs, OCaml, standard ML. ML was the inspiration for languages like Elm and Rust. It's super old and good because of that, right? A lot of this stuff has been figured out, over 20 years, so it's stable, mature. A lot of this stuff is figured out. And one of the shining points is the type system. I recently figured out what it was called. I was just like, this is kind of dope. But somebody in another talk was like, that's the Hindley-Milner type system. And I was like, okay, yeah, I'll take your word for it, dude. But yeah, it's cool. It's like really good type primitives, and the inference is banging. So, why should we use it? Right? Why do you want to write your stuff in a systems language? First and foremost, it's ridiculously fast. Particularly on the native side of things, right? When you're writing regular OCaml, optimized OCaml can be faster, if not faster than C. So, and a lot of the tooling that's reflected, and I'll show more about that later. So it's a functional language, and that's just tons of fun. But it has things like side effects, mutation, and other escape hatches that let you put it in prod, unlike other functional languages. Yeah, you can actually do things with it. Phenomenal language ergonomics. And what I mean by that is like when you're writing it, when the tool set that they're giving you, it makes it very pleasant to write. And I'm not saying reason about, I'm not doing it. And of course, a really nice type system, right? The biggest thing is that you can target both JavaScript and the native code. Right, so you're not just going to JavaScript like Elm or something like that. You could do the native and the JavaScript, and on top of that, there's a bytecode. Right, so the native compilation takes a little bit longer, but is faster. The bytecode isn't quite as fast, but it's really quick, and I'm going to show some hot loading examples later where it's ridiculous. So back to the JavaScript side of things. This is accomplished through a project called BuckleScript. I guess originally developed at Bloomberg. And what that does is it compiles OCaml to JavaScript. And because Reason is OCaml, just a syntactic extension, it also compiles Reason to JavaScript. And one of the cool things is what it actually spits out is pretty readable. So if you're looking at like the debug in the browser or anything like that, you're like, oh, okay, it's not ridiculous. And anytime you have a language that's not JavaScript, especially a typed one, and you're going to use stuff from it, if you're writing this and then you're going to pull in Lodash or something like that, you need your interop, right, so that you can keep your types sound, so that you're not bringing in JavaScript as a lie, right? You want to, if you're expecting something, you need to define that it's expecting a string or something like that. And then you can be sure that, reasonably sure that you're not going to have the runtime errors. As far as interop's concerned, it's probably the most pleasant for writing the bindings. And I can show you a little bit about that later. So I'm just going to show real quick what this BuckleScript's all about. I was saying before that it renders out. This is actual BuckleScript output. So as you can see, it's pretty readable in the grand scheme of things. It's not a lot of shenanigans. It's pretty terse. And it's actually a lot faster most of the time than you can write by hand. It's pretty optimized. You might be seeing stuff like this right here, these BuckleScript directives. And that's because some of these things don't exist in OCaml. Right? Things like Webpack CSS requires. Right? So you're going to see like a BS raw, or this is like a little binding to an image asset. Yeah, BuckleScript's the bomb. Now, also, with JavaScript as a target in mind, the OCaml standard library sometimes doesn't translate to the best JavaScript. I mean, it's not bad JavaScript, but they created a thing called Belt, right, which is a standard library for BuckleScript that knows that it's going to JavaScript and makes your compiled JavaScript faster as a result. So that's a cool thing to use. All right. Another point that I'd like to touch on is errors. The errors are absolutely incredible. If you ever used Elm and you were like, oh, wow, these errors are crazy, these errors are also crazy. Let me see if I could throw an error here real quick. Shouldn't be hard for me, am I right? Right. So I go like change a type or something that should be an int. Oh, okay, yeah. Fucking correct that. Thanks, bro. Yeah, so here we have this bug, and it shows you where the bug derives from. It's like, this is a float, and it should be an int. And then here, it then gives you recommendations. It's like, yeah, if this is a literal, you want a number without a trailing dot. Do what you want with that. But so the errors are pretty great. Yeah, you get it in the browser there too, as well as your VS Code. Get out of here. Okay. All right. So what does it look like, right? We're going to take a little look. It looks a lot like JavaScript, which should make everyone feel at home. This is valid reason here. This is a sum function, a little sum, right? I'm so sorry. I'm not sorry at all. I'm not even half sorry. So yeah, I mean that would work in your ECMAScript, whatever we're calling it, or Reason. So let's see what's different. Take a look at something funny. So you might see some weird stuff here, right? We could step through that. Here we have this sing hook function, and you see this tilde here, and what that is a named argument, right? So if you're not a positional argument fan, you want to name your arguments. You put the tilde there, and then when you call it, you can use that to supply it in whatever order you'd like. You might see this too, and this might be freaking you out, the old double plus. That's string concat, right? That's how you add strings together. Oddly enough, in OCaml, you're going to see a lot of, or Reason, you're going to see type-based operators. So like if we're adding a float, it would be like plus dot or plus period or whatever. So that's what that's all about. So let's look at some of these primitives. First up is records. I guess the closest equivalent in JavaScript is objects, right? It looks just like an object, right? It's actually like an immutable object in Reason. And the difference is that if you just write this part, is highlighting showing? Yeah, it is. If you just write this part, it's gonna have a problem. It's gonna yell at you because you didn't define the shape somewhere. And notice we're not putting an explicit type on this thing. It kind of just knows based upon the shape that this yay is a person, right? Because the shape matches. So anytime you use one of these, you do need to define your record shape. All right. Next up is variance, and the next two things that I'm going to explain are kind of the bread and butter of what makes writing Reason a little bit different than writing JavaScript, and it's kind of dope. But explaining them individually at first, you're going to be like, what? So bear with me. So a variant is kind of like a type and a data structure at the same time, almost like a TypeScript enum or something like that. So here we have this type status, right? And status can be one of any of the stronger lyrics. And that's pretty cool on its own. Doesn't look super useful. One thing that's a little bit different from like enums is that they actually accept arguments too. So we have this type album, and you only have two kinds: not worth listening to, and then Kanye albums. And it accepts a string if you wanted to specify which Kanye album. So here we say the current album is yay, the new one. It's really good, so went with that one. But yeah, you can construct them with arguments. And then, oddly enough, pattern match on them with arguments. Right? So the other half of variance is the pattern matching. Now it's going to look like a JavaScript switch, but it is not. So here we have this amount that equals 5. We say let result equals switch on that amount, right? So there's no case or anything like that. We have these pipes, kind of like when you're defining the variant. And this first one, we say amount when amount is greater than 5, we return whoa buddy. We have 5, which we return exact. And then we have this underscore, which is kind of like your default, and that's just going to return almost there. Now that's cool, but the real cool part you can't see here. If I were to remove this line right here, I'm going to get an error. And the error is going to tell me that my pattern matching was not exhaustive enough. So if there's a case that to be handled and you are not handling it, it's going to yell at you and make you handle it. And for someone who writes terrible code like myself, it's good to keep me in line. Speaking of handling things, another thing that adds a degree of confidence to your programs is there's not really null in Reason, right? You have an option monad, right? It's a built-in variant type called option, and you can either have none or you can have some with an argument, and the argument is some of whatever it is. So here we have this print list method. And it takes a list of things. So we have the switch, which is our pattern matching on list of things. So if there's none, right, we just return an empty list. If there's some with a list argument, we return the list that is the argument, and the return of that goes to this pipe here, pipeline operator, which is too much fun. And it pipes it to a log. So it'll render out either an empty list or the list that you provided it. Now down here in print list, you're going to see that I'm explicitly saying some there, right? I'm passing it some with a list in there, and the reason is because we're doing this pattern matching here on the option type, this is expecting an option type. I can't just pass a list. It'll say it knows based upon the context, the interior logic here, that this should have an option type. Right? So here you need to explicitly say that. If you're doing something like using like a BS fetch library, BS is the BuckleScript prefix for libraries. A lot of the time it'll kind of just return some or none by default. So usually they're not doing it as explicitly, but that's what that's actually all about, right? So this is a little bit of a brain twister, and this is really, really different, and that's the module system. So this is bananas, okay? So unlike JavaScript, you don't have any import or export, right? You're not really like importing all from Lodash. Right? And what they're like mini files or maybe like namespaces. So not only do you have like the file level scope, but you can define modules explicitly inside of those files. So every single .re, which is the reason file, every single reason file is a module that is in scope of every other reason file in your project. And you can nest in there and you can create new modules. And I'm going to show kind of how that works in a second. Like here, like this is an actual thing that I put in prod, and this is reason files right here. For each one of these, right, there's like capital C close button right in scope. Like if I'm in info, I can use close button. I'll show you what I mean. So say we have test.re, and then in here we use let to define module property. Let module property equal Yeezy 350 v2, which are pretty dope. I mean, I like the original Yeezy 350s, but the v2s are okay. I'm looking forward to seeing v3s personally. And then in index.re, if we say print endline, so in this completely different file, we just, out of nowhere, just say test.module property. That works because this is not tests because this file exists and is adjacent to this file. That just works, right? That's just there. You might be saying, this is a little nuts, but it's actually kind of nice once in a while. Your files are a little bit more terse, and it's a good time. So here in test.re, right, we can define a module inside of the file level module scope. Here, we're gonna say nested, right, and then we're gonna say handsome fellow, believe it or not, equals Ken Wheeler. And then in index.re, right, you can print endline, right, you're gonna print out test.nested.handsome fellow, and then string concat is handsome AF though. Okay? And then here you can do, so this is a different thing. This is open, and open is a little bit of a brain twister in itself. Imagine if you could take the scope of a JavaScript module and kind of just vomit it on the inside of a file, and then in your scope, right? So if I have test, right, my test module, which is kind of like globally available, and it's like test.nested, if you just want to go right to the nested, if you just want to insert that into the file's current scope, you do a thing called open, right? You don't do it that often. A lot of the time I'll just do it with something that like you're using incredibly heavily, because sometimes it'll mess stuff up, but that actually works and is bananas. Another way that you can do that, which is a funny thing that I kind of choked on at first. I was like, what's going on here? You can start doing like the dot notation on these modules, and then do dot parens here, and then anything inside of the parens, you can do multi-line, whatever you want. Anything inside of these parens operates within this scope, right? So you can just go right to handsome fellow right there, and sure enough, that's going to print out Ken Wheeler. All right, so let's talk for a second about the bindings. It's cool and all to write stuff from scratch, but obviously at some point, if you're putting something in prod, you're going to want to use libraries, right? So what you need to do is write bindings for them, right? So what it does is it bridges the JavaScript to the reason, and it keeps your type system honest. Your type integrity is only as good as your bindings and being truthful and diligent in the writing of said bindings, right? Another thing that it lets you do, right, because it's kind of like this interstitial transformation kind of thing, is it gives you an opportunity where if you have like an API in JavaScript, to rethink that API and make it more reasonable. Don't clap for that. So this is what like a regular binding would look like. So right, remember things are in like kind of like top level scope. So here I have this GraphQL tag.re. This is the GraphQL tag you call BS module, right? And then this external GQL, right, which is going to give you like the kind of like the default export there and assign it to GQL. You're going to say the string is going to return these GraphQL definitions, an array of definitions. And then in here, your top level export from GraphQL tag is this GQL, where you have it takes a query and then it'll call this one right here. So this is the point at which, if you were going to do something with the API, you could have this take different arguments or something like that, and then kind of just call against that JavaScript one there, right? And then using it kind of looks like this. This bracket pipe thing is a multi-line string, right? So that's how I'm doing GraphQL here. I did it like this, but I'm also a dummy. Since then, people have done things where you can type out the whole GraphQL query. I'm just not smart enough for that, so you're going to have to deal with this. So one of the cooler bindings, right? The folks who made React made Reason. They actually made React, the initial prototype, in not Reason, but standard ML. So naturally, you're going to have ReasonReact, right? The first class React bindings, where they did take an opportunity to work on the API, right? And this is what it looks like. It's like future React style. So I'll break this down for a second. Here you kind of create your component, right? You have ReasonReact stateless component. So we have a stateless component, and the name is app. This make is kind of like if you look at like dsugar JSX, and you have like the create element or something like that. That's like essentially what this is happening right here. We have our message, right, which is a named prop, and then we have our children, which are the arguments here. And then you can spread, right, this component inside of here, right? That's what kind of brings it to life. And then you have this render method. And here you have self, and I kind of wish we had this in React. Self has things like props, state, etc. And it's kind of cool. It's like if you had like this, like right there in the self is like thisy, right? And it's right there in your render. So here it supports JSX, like first class. One thing that pisses a lot of people off initially is this right here. So let's have a chat about this. So you can't have like free-form text elements right there in your JSX. So you have to do this explicit casting, ReasonReact.string with the message. Message is, presumably a string, and it'll, you don't have to say that. It kind of just knows that because we're doing string. You got to do the same thing with arrays, and that's that it's annoying at first. You're like, really, we're gonna do this, and then you just kind of take it and pipe it to string, and you feel all functional and cool, and then you can like look down on your friends, and then all that goes away. Okay. So I'm going to actually show stateful components for a second and list components. We could take a little look here. I got to pick up the pace. It looks like I'm running out of time a little. I don't know. Is there a timer? I don't have the get off the stage button. So yeah. So this is a stateful component. We have so you define your state type up top, right? And then it's a lot like Redux. You define variant action, right? So this action is variant type. We have increment and decrement. And then here, this is a little bit different. Here we have reducer component. I'm going to go ahead and bump this up. Blow. Okay. So we have our reducer component, and you have the name like before. You spread it in here, but this is a little bit different. We have this initial state here, right? It's a function that returns a record, right, that matches the shape of the state that you defined up top. And then you have a reducer, built-in reducers. What is this? And that takes an action and a state. You go and you pattern match on the action that was sent to it. And then depending on the one, you call ReasonReact update and then return your new state, right? So you have this reducer. The way that actually works, the way you call this reducer is here in render you have self, and then if my button gets clicked, you call self.send with the action variant that you want to do, right? So you have these, you're like, hey, I want to increment, I want to decrement. That's how that works. I'll pop over real quick and just show you how lists work, because that was challenging at first. Here, I'm actually defining an array. There's a list type, and then there's an array. The array type is mutable, but here I define the array. You can tell it's an array because it has the pipe instead of just the bracket. Stateless component, spread it out, da-da-da-da-da. Unlike in JSX, you do it with the parens rather than the brackets when you're doing shenanigans inside of here. So I have my items. I go and pipe them to array.map. If it was a list, I would have to cast it to array before getting to ReasonReact.array anyway. But we map over it, wrap it in LIs. We have a good time. And then pipe it to ReasonReact array, which is a similar thing to like ReasonReact.string, where it's just going to create those elements for your final output, right? And that is stateful components. The next thing I want to talk about is BS React Native. It is a bunch of BS. So it's BuckleScript bindings for React Native. And it's actually pretty sweet. React Native is a great use case for Reason. You can see here it's a little bit different than you would normally do things, but that's great. Like styles are typed. So like here you have like style.flexDirection, right? And it'll only take column. You can't provide this a bad value. Or I mean you can, but it's going to catch at compile time and not run your app. So it's a really good way, and like native mobile apps really don't handle errors that well. They kind of just collapse and die. So I think it's a great application for that. I did it. I wrote the Seattle JS conference app in Reason using BS React Native, and it was lovely. I was on a plane, and the plane did not have Wi-Fi. But I was able to continue to work with confidence because I wasn't getting any compiler errors. And then when we landed and I got to my hotel room and booted it up, the app just worked. So that was kind of a testament to, you just fly blind. And then, this is reroute, right, which is a router done in Reason. And before I was telling you about how you can kind of like re-envision things in Reason. Here, right, you see that the pattern matching is perfect for route, it's expressing router logic. So yeah, it's pretty cool. It's tight. There's another thing that I wanted to show you, which is really cool. I'm going a little bit over, but I'm wrapping it up. It's called Reprocessing. If you haven't heard of the processing library, it's like a graphics kind of playground sort of thing that you can do in OpenGL or WebGL. So it was ported to Reason. And there's this library called Reprocessing, and I'll show it to you. Whoop, hey now. Yeah. So in here, I mean, it's pretty simple. You just go reprocessing, run. It's no React, right? You have setup and you have draw. Draw gets called on the tick, right? It's like immediate mode rendering. And then in here, every single tick, based upon variables, you can draw. You could just do like graphics drawing. So let's see what that's all about. All right, do a little npm start. Don't play games with me. Isn't it not done? Really? Are we really going to do this right now? Yeah, okay. So this draws a draggable square, right? And that's pretty cool. I mean, it's not that cool. It's a draggable square. But I want to show you, remember before when I said it was fast? Check this out. Okay, so if I hit 0, I might even hold this sideways just so you can see my finger hit. Watch. That is how fast the hot reloading is. Okay? It is fast! Now, you might say to yourself, that's cool. It's a stupid-ass square, like, oh, the square is fast, da-da. But, you can actually make games with this, and they compile to native Android games, native iOS games. It runs WebGL on the web, and it'll do desktop. And, I made one. It's called Top Speed 2069. It's like a car game. It's way too much fun. But yeah, I mean, you can do some really crazy stuff with it. All right, I'm running out of time here. So, how to go ahead and get started with this. Because you're obviously, every single person here is going to try Reason after this talk, right? And we can forget about that whole circle game thing. Okay, whoop. So how to get started, there's a couple ways. If you're going to do ReasonReact or just regular JavaScript Reason, you npm install GBS platform. And then from there, you can use BSB and init to scaffold out applications. You can use this theme argument to do like a React app or just like a regular one. And that's a great way to get started there. Say you're afraid of commitment and tooling and stuff like that. You just want to give it a hot try. One good way to do that is with Replit, which is amazing, might I add. But in it, one of the vast amount of languages that they support is ReasonReact. So you can come over here and you can just bang it out right in the browser and have fun. This is the ReasonReact starter. So you can try it there. If you want to do like a notebook style thing, there's this sketch.sh, which is kind of cool. So you can sketch out some stuff here, like Python notebook style, and send that to your friends. And it's a good time. So everybody go ahead and try it, and thank you. Have a good day.